Section 10.3, Simplifying Radical Expressions. Number 2, the cube root of 2 times the cube root of 7. We're supposed to use the product rule to multiply. The product rule is given on page 603 of your text. It says that we can rewrite this expression under one radical symbol as long as the roots of the two radicals are the same. And they're both root 3. So we multiply the 2 times the 7, and we get the cube root of 2 times 7, which is the cube root of 14. And that's our answer. Number 3. Use the quotient rule to multiply the square root of 5 over 16. The quotient rule is on page 604. It says when the roots are the same on two radicals, you can rewrite the radicals as separate radicals. You can rewrite square root of 5 over 16 as the square root of 5 over the square root of 16. And since 5 is not a perfect square, we can't simplify it anymore. So we leave it as the square root of 5. And then the square root of 16, 16 is a perfect square because 4 times 4 is 16. So the square root of 16 is 4. So the square root of 5 over 4 is our answer. Number 11. Simplify the square root of 81 times x to the power of 5 times y to the power of 13. By the product rule, we can rewrite this expression as the square root of 81 times the square root of x to the 5th times the square root of y to the 13th. Now, 81 is a perfect square. The square root of 81 is 9. But the next two factors are not perfect squares. So we simplify them. To simplify x to the power of 5, we rewrite it such that we rewrite it as factors where one of the factors is the highest even power that we can have. X to the 4th in this case. And the other factor is x. So we factorized x to the 5th as x to the 4th times x. This makes x to the 4th a perfect square. We do the similar thing to y to the power of 13. Y to the power of 13 can be rewritten as y to the power of 12, which is the highest even power that we can make, times y. So we factorized y to the 13th as y to the power of 12 times y. This makes y to the 12th a perfect square. So then by the product rule, we separate the radicals again. We write 9 times the square root of x to the 4th times the square root of x times the square root of y to the 12th times the square root of y. Now, to get the answer in the last line, we square root first the perfect squares. So x to the 4th is a perfect square. So we square root that by using the fractional exponent rule. X to the 4 over 2, power on top, root on the bottom. X to the 4 over 2. 4 over 2 is 2. And that's how I got x to the power of 2 on the last line. To simplify the square root of y to the 12th, y to the 12th being a perfect square, we convert that we simplify it by going y to the 12th over 2. Y to the 12 over 2. 12 over 2 is 6, and that's how we get y to the 6th on the last line. Times, using the product rule, the square root of x times y. So we get our answer 9 times this x squared times y to the 6th times the square root of xy. Number 13. Use the quotient rule to divide, then simplify. And the expression is 6 times the fourth root of 162 divided by the fourth root of 2. Now, because the radicals are the same, we can combine the 162 divided by 2 under one radical sign. So we have 6 times the fourth root of 162 over 2. Then we divide 162 by 2 and we get 81. Now, to get the fourth root of 81, we want to keep factorizing 81 until we get 4 factors. So first it breaks down to 9 times 9, and then 9 and 9 are 3 times 3, so we have 6 to the fourth root of 3 times 3 times 3 times 3. Well, that's 3 to the power of 4. And 3 to the power of 4 is the opposite operation of the fourth root. So the power and the root cancel each other, leaving us with the 3. You could also think of that as 3 to the 4 over 4, using the fractional exponent rule, and 3 to the 4 over 4 is 1. So again, we have 3 for the fourth root of 3 to the 4th. So 6 times 3 then is 18, and 18 is our answer.